March Dental presented the artegral ImCrown system at the International Dental Exhibition in Cologne in April. The system will be put on the market in October this year and is intended for users of the CEREC InLab system and the CEREC 3D system. We visited Markus Dubke, a dentist in München-Gladbach, at the end of August to see the system in operation, and filmed him fabricating a long-term temporary restoration in which artegral ImCrowns were used. Adhesive is applied to the tray for retaining the impression material. It is also practical to use a bite stop made from light-curing resin. The tray is filled up to the palatal vault with economy C silicone. Stops are placed distally to prevent impression material exuding. The stock tray now functions in the same way as a customized tray. The abutments for the planned long-term temporary restoration had already been prepared during pre-treatment. The preparation margins are again checked at this stage and smoothed using Sonixys and rotary instruments. The gingiva is retracted slightly before the impression is taken. Here, the painstaking technique of placing retraction cords is replaced by a simpler method. This silicone material expands during and after setting, causing the gingiva to retract. This method is ideal with these types of isolated tooth preparations. The time required is just under 10 minutes. The impression is taken using the multiple mix technique. The dies can also be scanned with the CEREC 3D camera. A CEREC InLab software update is required for converting the data obtained. In this case, the dental laboratory will fabricate the long-term temporary restoration. The laboratory has been using the CEREC InLab system for several years. The model was fabricated with a special scannable plaster. The dies of the model are now scanned with the INEOS scanner. The scanned model die appears on the monitor. The software uses the data to produce a virtual model that can be freely rotated and tipped. The virtual model can also be trimmed. The preparation margin is now outlined. This is relatively easy because most of the margin has already been defined by the system. The preparation line can, of course, be individually adjusted. Industrially prefabricated artegral ImCrown crown blanks are used for the abutment crowns of the bridge. The appropriate artegral ImCrown blanks are selected from the tooth database. These can be customized on the screen. The software tools can, of course, only be used to make the blanks smaller, not larger, as the blanks have been industrially prefabricated. Characterization, for example, abrasion facets, can be added. A blank in the correct shade is then clamped in the CEREC InLab milling unit. The milling instruments are calibrated automatically to the blank. The milling paths of the cutting instruments had already been determined on the computer. The blank is milled to the correct shape. At the same time, the inside of the crown is milled out to the same shape as the tooth preparation. The service life of the cutting instruments is greatly increased due to less material reduction. The crown is finished in about 15 minutes. The milling paths are very close together, so preparation does not require much time. After preparation and polishing, the crowns are fitted on the master model. An appropriate mold is selected from the integral anterior tooth range. A wax setup and silicone index were fabricated together with the crowns. The teeth and crowns are carefully roughened to ensure an optimum surface for a reliable bond of the tooth-colored resin, which is used to splint them to form a bridge. The denture teeth and crowns can now be quickly transformed into a bridge using the silicone index. The denture teeth and crowns are connected together palatally, labially, and buccally with tooth-colored cold-curing resin. Both layers of cold-curing resin are cured in a pressure vessel. The bridge is then prepared. Adjustments, for example additions, can be easily made after the first try-in. The bridge is then finished and polished. The natural aesthetics of the bridge is impressive even at the try-in stage. As the fabrication technique saves a lot of time and uses minimum material, this is an ideal system for producing a cost-effective, highly aesthetic, long-term temporary restoration.